Today we are going to review greatest common factor, which you learned in middle school, but then we're going to add exponents to it. So starting with this question, we are trying to find the greatest common factor between 12 and 36. There are several different ways to find the greatest common factor. The most common way you probably saw in middle school was to list out the factors for each number. So for example, to get 12, we could multiply 1 and 12, 2 and 6, or 3 and 4. To get 36, we can multiply 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. What you're trying to find is the greatest factor that they both share. So in this case, the GCF would be 12. Today we're going to do the exact same thing, except this time we are going to add exponents to it. So if you look at 5x squared, we can multiply 1 and 5 to get 5. And then x squared means we have x times x. For 100x cubed, we can multiply 1 and 100, 2 and 50, 4 and 25, 5 and 20, or 10 and 10. The greatest factor that they both share is 5, and then 100x cubed has x times x times x, which means that they share two x's in common. Combining those together, our GCF between these two is 5x squared. I can take out two x's from each one, and I can divide both by 5. You should get to the point where you can name the GCF number just by looking at it. So if you look at this, between 4 and 32, I know that 4 can go into both 4 and 32. So my GCF starts with 4. I have x squared and x to the 5th, so I can take 2 from each of those. I have y and y squared, so I can take 1y from each of those. And I have z to the 4th and z, which means I can take 1z from each of those. Whenever you're dealing with your exponents, you're going to take the largest amount that you can take from both. They have to have it in common. So now take a second and try these three. Pause the video and see how you do. For number 1, you should have gotten 2x to the 5th. 2 is the biggest number that will go into both 20 and 42, and then you can take 5 x's from each of those. For number 2, you should get 13m n squared. I can divide both of those numbers by 13. I can take 1m from both of those, and the greatest number of n's I can take is 2 from each. Now, on number 3, there is not a number in common that can go into both 7 and 41. When that happens, you can divide both of them by 1. I can take an a from each of those, and I can take b squared from each of those. If you wrote number 3 as just ab squared, that works too. Now we're going to take the GCF out, and we're going to see what's left. So this is kind of like backwards distributive property. First, looking at 3x squared and 15x, the biggest number that will go into both of those is 3, and I can take out an x from each of those. Remember from Unit 6 when we divided exponents, I'm going to divide both of these by 3x. So I'm dividing the number in front, I'm subtracting my exponents. 3x squared divided by 3x is just x. 15x divided by 3x is 5. These are super easy to check because you can just distribute them back out. If I distribute 3x times x plus 5, 3x times x is 3x squared, and 3x times 5 is 15x. I got what I started with. This one is the exact same, except now I have 3 terms. All 3 of these numbers can be divided by 4, so I'm going to take 4 out. And then I can take, the greatest number of x's I can take is x, because this last term only has 1. When I take that out, 4x cubed divided by 4x is x squared. 16x squared divided by 4x is 4x. And 20x divided by 4x is 5. Remember, you can check this by distributing it back out. 4x times x squared is 4x cubed. 4x times 4x is 16x squared. And 4x times 5 is 20x, so I know it worked. Now, another thing I want you to remember is when you're taking out the GCF, if there's a negative in front, I want you to take that out with it. So in this case, I can divide all three of these terms by 5, and since my first term is negative, I'm going to take out negative 5. I can't take out any x's on this problem because 5 doesn't have any. Whenever you take out a GCF, it has to be able to go into all three factors. Now, when I divide all three of my terms by negative 5, be careful with your signs. Negative 20x cubed divided by negative 5 is positive 4x cubed. 100x squared divided by negative 5 is negative 20x squared. And 5 divided by negative 5 is negative 1. Don't forget to write that 1 in. Now, if I want to check this by distributing, negative 5 times 4x cubed is negative 20x cubed. Negative 5 times negative 20x squared is 100x squared. And negative 5 times negative 1 is positive 5, so it works. Take a second, pause the video, and try these three on your own, and then restart it and we will check. For number 1, the GCF that you can take out of both terms is 2, and when you take that out, you are left with 1 plus 2n squared. For number 2, I can divide both of these numbers by 8. I can take out an x from each one and a y from each one, and when I do that, I'm left with 2x squared plus y. And finally, on number 3, you can take out a 5 from each of these. I can't take out any variable. Actually, I can take out a b. And when I do that, I'm left with 10ac minus 2c plus 1.